All right, so last time we left off having talked about compound sentences, or compound statements rather. And our compound statements were joined using, we're talking about 3 different kinds of connectives. One of them was the and connective, which is called conjunctive. One of them was called the or connective, which is called disjunctive. And then the last one we didn't actually get to, although we introduced the idea of it. It's called a conditional, if-then connective. So a statement that's expressed in an if, P, then Q form. Also, we read it sometimes as P implies Q, because you can kind of read the arrow, so it has the name implies. And then the notation is P and an arrow and a Q. Hypothesis is the if part, and then the conclusion is the then part. So the if part. And it doesn't always necessarily come at the beginning versus the end, so you're going to see that as well. But whatever is connected to the if part of the statement, that's the hypothesis, and whatever is connected to the then part is the conclusion. So we're going to take some verbiage and we're going to create these. So the first one we're looking at says P is going to be the statement you build it, and Q is the statement they will come, which is from what movie? Dreams. You guys do know it. That's great. If you don't, it's okay. All right. So notice on part A, this one actually has exactly the feature that I had just mentioned. The if part is not occurring at the beginning of the sentence, is it? It isn't. But that's okay. All right. That doesn't affect anything. It just means that when I write my symbols with the P's and the Q's, they're not going to follow the order of when the sentence looks. We're going to start with the if part. If you build it, right? So, if you build it, well, you build it is what symbol? P. So I'm starting with P. Because it's an if-then, it's going to have an arrow. And then the result is they will come. And that has symbol Q. So writing down they will come if you build it, or if you build it they will come, is the same argument. And it's written in the same form. It's just sounds different when we put it in a sentence. Okay? But it means the same thing logically. If you do not build it, so here actually the if is at the beginning, so we're going to start at the beginning of the statement. If you do not build it, well, what symbol would that be? A little squiggly, tilde, P, right? If you do not build it. And then we always have an arrow for the if-then conditional. And then they will come as still Q. Just as we want to be able to take a sentence and turn it into symbols, we want to be able to take symbols and turn them into a sentence. And that's the next slide. Okay? All right, so changing what P and Q are meaning. P means God loves me. It's good. And Q means I'm a sinner, and that's not so good. Right? It says write a sentence that represents the following symbols. Now, the first one, notice there is no arrow in it. What does that symbol in between mean? And. Okay? So we want to make sure that we're interpreting this correctly. So the first thing we see is P, and what does P mean? God loves me. So I write down God loves me. And then I have the and symbol, so I'm going to write the word and. And then it says Q, and Q would be I'm a sinner. Okay, God loves me and I'm a sinner. And that's the language, the sentence that we associate with those symbols. Now in part B, we actually do have that arrow, which means the easiest way to write this is to start out with what word? If. That's the easiest way to write this. And then we start out with the tilde Q part. And what does tilde Q say? I am not a sinner. So I've got the if, I've got the I am not a sinner, and now I have an arrow, which means I'm going to write what word next? Then. Then what? Then God loves me. And if I'm not a sinner, he does love me, but the truth is, I am a sinner, right? So this statement is fine to write. It imagines all the symbols that are there or whatever, but it doesn't have any sort of valuable meaning to us because the first part is already a false statement, right? All right. Contrapositive. So a contrapositive, and if you took contemporary math, you also learned about converse and inverse. They aren't highlighted very strongly in the book, so I'm not going to talk about them. We're just going to talk about contrapositive. What a contrapositive does is it takes a statement and it changes the order of the implication. So if we had P and then Q, now we have Q at the front and P second. So it changes the if and the then, it switches them. And it also negates both of them. All right? So it switches them from being a positive statement to being a negative statement, or vice versa. So if you're taking a look at this one, this is similar to the last ones that I just described. The first thing that we would do, so this example says create the contrapositive. Oh, let me make one more statement. I'm sorry, it's in orange. Note these statements are logically equivalent. So when you change the order of the implication and you negate them both, you actually end up with a logically equivalent argument to the one you started with. Okay? So that's what we're actually going to do on this. We're going to create the contrapositive. This says, if I am a sinner, then I am saved by grace. Okay? So I'm going to write down the if, and then what's going to come next? All right, so we take the part that's at the end, right, Kayla? And we bring it to the beginning. And we also negate it, which means we introduce the logical opposite. So instead of saying I am saved by grace, it would be I am not. So if I am not saved by grace, then, and now I go back to the beginning, what will I say? Then I am not a sinner. And this is logically equivalent to the first statement, although it sounds very awkward because it has so much not in there, doesn't it? I've got not in there twice, and I've got the implication sort of looks like the opposite order of how we think about this kind of a statement anyway, but it is a logical equivalent to the one we started with. I always mention when I teach contemporary math the practical importance of understanding logic, and here you see something like this. So if somebody says this last sentence that you just created to you, you might look at that and say, well, that doesn't sound right, and it doesn't sound right. But what you mean when you say it doesn't sound right is it doesn't make sense, right? Or I don't believe it's true. And when you think about, courtrooms and the logic that lawyers use and things like that, you have to be able to wade through what was being said to actually what they're talking about, right? That's what's going on here. What does this actually mean? Well, it'd be a lot easier if I said, if I'm a sinner, then I'm saved by grace, than to say the statement that I just created, right? But they are logically equivalent. So I think that was the last one we had. It didn't have us do this, although we certainly could. Your book, one of the other things that's interesting too, and I don't know why they didn't, but because they didn't, I'm not going to go into it. This talked about them being logically equivalent, but it didn't show you a truth table to show they're logically equivalent, right? Because we talked about logically equivalent last time we did some truth tables with them. The reason that I'm not showing you the truth table to show they're logically equivalent is because I haven't really shown you how to do a truth table for a conditional statement. For those of you who had contemporary math, you saw that in that course. But this textbook, at least to the best of my knowledge, and of course I didn't read every single word in the chapter, but as I was looking through it, I didn't find where it's showing you how to do a truth table for an implication. So that's why I'm avoiding showing you that at this point too, to show they're logically equivalent. But if I were to show you a truth table and I showed you both these statements, you would find that they are logically equivalent. Okay?